Hello, I'm Cameron Duffield and I'm presenting our paper, Magnetic Force-Driven Wireless Motor. Magnetic control is often used for wireless actuation of microrobots. It can be used for robot locomotion, or in the case of soft robots, it can deform the entire structure of the robot. However, current magnetic control moves the whole robot as a single body, or deforms it as one continuum. Our aim was to develop a magnetically actuated motor which experiences no net force from the external magnetic field. We did this by using two magnets to apply a force to a rotator crankshaft. The magnetic field is provided by a single horizontal coil, which significantly simplifies the control compared to other similar approaches. The mechanism uses two ratchets to convert the oscillating motion of the input crank to a continuous rotation of the output crank. Each crank arm has a magnet in the end with opposite orientated magnetic dipoles. This ensures that there is no net force acting on the motor. First, the magnetic field gradient is applied downwards, driving the crank from the top of the stroke to the bottom of the stroke. When the crank is horizontal, the greatest torque is transferred to the input shaft. When the crank is at the bottom of the driving stroke, the torque is at a minimum. The magnetic field gradient is then reversed for the recoil stroke, where the crank moves back up to its starting location, ready for the next driving stroke. The first experimental result was demonstrating the motor worked. Following this, we modelled the output torque for a given angle of the shaft. This is covered in more detail in our paper. To experimentally validate this model, a monofilament thread was wound around the output shaft and taken up over a pulley with a known mass hung from the end. The mass was increased until the motor stalled for a given magnetic field gradient. This corresponded to the minimum torque, where the crank is at either the bottom or the top of the stroke. As can be seen in the graph, this was a reasonable fit for the model. To summarise, we developed a magnetically actuated motor capable of continuous rotation, which experiences no net force from the external magnetic field. We also modelled the output torque of the motor and experimentally validated this model. Thank you for listening. Do we have any questions?